First part is express u in the form of x plus iota y. So we will be rationalizing this by multiplying and dividing with the conjugate pair of the denominator. Okay. So the denominator will become a squared minus b squared. And we know this is -1. So we get 4 minus -1, which is 5. And in the numerator, we have 6 plus 3 iota plus 2 iota plus -1. So we have 5 plus 5 iota, which gives 1 plus iota as the final answer. Part 2 is find the modulus and argument. So for that, it's better we sketch it on an Argand diagram first. Real part, imaginary part, this is the point. We will find the modulus. This is going to be square root of 1 square plus 1 square, which is under √2. And this angle theta, which will be tan inverse 1/1, which is going to be pi by 4. So we have the modulus of u and the argument of u. Okay. Next is sketch an Argand diagram showing the point representing the complex number u. Show on the same Argand diagram the locus of points representing the complex number this. All right. So now we draw a proper Argand diagram for part 3. So 1 plus 1 iota could be here. Okay. And we have to mention real z and imaginary z, or x and iota y. Okay. So now this means we have to draw a circle whose center is the point u, this is the point u, and whose radius is 1. So that means it's going to be something like this. This is going to be 2 right here, and this will be 2 as well, and this will be 0. In fact, this should be a tangent to the x-axis and the y-axis. Let me try to do a better job with it. So a circle passing through these points exactly, this would be 2, that would be 2 as well. So something like this. Okay, so the x-axis and the y-axis needs to be tangent to this. Okay, that's done. Okay. Next is using your diagram, calculate the least value of z for the points on the locus. All right, so least value of modulus of z means we have to look for the smallest distance between any one of these points and the origin. So the smallest distance is definitely going to be between the origin and this point. That's going to have the smallest possible modulus in this on this entire circle. Choose any other point. Let's say if we choose this point, this has a bigger modulus. Or if you choose this point, this has a big modulus as well. Only this modulus, if you choose a point here, that is going to be the shortest modulus possible, or the least value of modulus of z. All right, now how do we find this? We know that this is 1 and this is 1 as well. That means this is mod square root of 2. So the full length is from the origin to the center is square root of 2. And this is 1. That's the radius of the circle. That means this remaining part, this small, let me use another color. So this length is going to be square root of 2 minus 1. And are they asking for an exact answer? No. So we can give decimal answer as well, 0.41421. So smallest value of modulus of z is 0.414.